Good evening, students. Today we'll discuss about queue. A queue is a linear data structure implemented in FIFO, first in, first out manner. In queue, insertions can take place at the rear end and deletions can take place at the front end. In queue, elements are deleted in the same order as they are inserted into. Like this is an example of queue. In this queue, you can see insertion will take place from one side and deletion will take place from another side. From where insertion will take place, that will be known as rear, and from where deletion will take place, that is known as front. Operations on a queue. Push inserts an element to the rear of the queue. Pop removes an element from the front of the queue. Display displays all the elements of the queue. Now push operation. Here we are going to implement with the help of array. So front and rear both are 0 in the beginning, that indicates underflow. In the beginning, front and rear both will be at the same location, that indicates underflow situation, that means empty. When we have to insert the first number, the number will be inserted at rear location and then rear will be post incremented, means after insertion the rear will reach to the next index. There will be no change in the front. Suppose now you want to insert the next number will be inserted on the current rear place and the rear will be post incremented. Same process for the next number will be inserted on the current rear location, rear will be post incremented. The next number on the current rear location and rear will be post incremented. Like this way, when rear will reach to the size, that situation becomes overflow, that means queue is full. Pop operation. In pop operation, front and rear is 0, so that will indicate underflow, that means there is no element in the queue. Suppose currently front is on 0 and rear is on 4. If you want to delete a number, so the number 3 will be deleted from the queue, and after deletion of 3, front will be incremented, that means the update of front will be post increment. 3 is deleted and front will be shifted to the next location. For deletion of the next number, firstly 5 will be deleted and front will be updated to the next place. There is no change in the rear. For deletion of the next number, firstly 7 is deleted and front is updated at 9. Rear will remain on the same location. Now 9 is deleted, front and rear will reach to the same location. So whenever front and rear are on the same location, then we have to reinitialize. Why? Because now queue is totally empty and now the process will again begin from the 0. So we have to reinitialize front and rear again 0. Whenever front and rear will be equal, we have to reinitialize. Now let us see with the help of program. A queue is a class. Data members A array to hold the integer elements. Max stores the maximum capacity of the queue. Front to point the index of the front. Rear to point the index of the rear. Queue parameterized constructor to initialize the data member max is equal to cap, front and rear 0, and create array. Void push rear intb to add integers from the rear index if possible, as display the message full from rear. Void display displays all the elements present in the queue. So let us design the program. Class queue int a square bracket max front rear queue parameterized constructor max is equal to cap, front is equal to rear is equal to 0, and then allocation of the array, as we have discussed in the previous program also. When array is already declared, during allocation we don't write a square bracket again, so you will write only a is equal to new int max. Array is allocated. Now void push rear intb, if rear is at max, that means full from rear, we cannot do more insertions. Otherwise a of rear plus plus is equal to v. Why rear plus plus? Because rear is already at 0. So firstly the number will be inserted at 0 and then there will be increment of rear. So update is post increment. Int pop front. If front is equal to rear and front is not 0, then front is equal to rear is equal to 0. As we have discussed in the theory, if front and rear both are at the same place and front is not 0, that means ki all the numbers are deleted from the queue. So that time we need to reinitialize. So front is equal to rear is equal to 0. This is the reinitialization. So this is a separate condition required in pop front. Now if front is equal to rear, then list is empty and return minus 999 as per the question. Else return a front plus plus post increment of front. Why? Because the number which is available on the front will be returned first and then the front will be updated. Now void display, if front is equal to rear, that means list empty, else a loop will start from front to less than rear. Why? Because rear is indicating the index where number is to be inserted. So the actual number is present before rear. So the loop will start from front to less than rear and system.out.println a of I. So I hope you like the video. Thank you for watching.